Okay guys, this is the first of a few videos that we have for today. You can use as many or as little as you want, but keep in mind the idea on each of these things you're going to be looking at. And this is the worksheet we're going to be going through today, so if you're not there, get there. You want to make sure that you are graphing or using a table to figure out the solution, the common solution that we just talked about on the MDC that you guys completed yesterday. Or in other words, where do the lines cross if you graph it? That would be the point of intersection. It's also the only point that's on both of them. So for each question, I'm going to go through how to graph it, one way or the other, look for the common solution, and if there is one, we're going to substitute it back into the original equations to make sure that it makes both of them true. That's how we tell that it can be a good common solution. So for the first question that we had, we've got number one, as you can see at the top of the page there, and they say y equals x minus 2. Well, that should be a pretty easy one to graph because that's in that nice slope-intercept form. A lot of times you guys say y equals mx plus b. We've got everything we need with that one. But the second one is still the equation of a line, even though it says x plus y equals 10. And it would be okay if you guys decided to take every one of these equations and write them in slope-intercept form and find out where they crossed. I'm probably not going to do that because I think it's important to look at the relationship between x and y, and it might make a little more sense why we have lines where we have them if we don't look at everything in the pattern of y equals mx plus b. So when it's appropriate, I'll do that. When it's not appropriate or not the best way to do it, then I will not. But you are welcome to. This is not certainly the only way you can do any one of these graphs. So I've got my graph paper, and like we said, the first one is in slope-intercept form, and when it's available and when it's useful, I am going to go ahead and do that. When we look at it, negative 2 would be the y-intercept that you see on your graph, so there's negative 2. The slope with an x there going to be 1. Now that's actually enough points to make a graph, but you're going to want to go ahead and use that slope appropriately until you get out for a little ways, and then you can make a decent line that follows that pattern, and I think that's going to be more than enough points. And there's the line y equals x minus 2. So I'm just going to label that so I know what it looks like when I'm looking at that actual paper. Then you're going to go to the other one. Now look at the relationship between x and y in this equation you can see on the highlighter on the screen. The value of x plus the value of y has to equal 10. X and y represent numbers. Those numbers might change, but they always have to add up to 10. So probably a couple really easy things to graph in this case would be like 0 and 10. Like if x is 0, y's got to be 10. I know that because of the relationship between those two lines, and I didn't need a y-intercept or a slope to tell me that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is 0, 10 on our graph. So that is one of the points on this graph because 0 and 10 add up to 10. Another really easy thing to graph in this one, well, if x was 0, y had to be 10. If y is 0, then x has to be 10. And 10, 0 would be over here somewhere. And you notice I'm counting over 10 this way as well. Those lines, those dots that I just put, those points that I plotted, are pretty far away from each other, and I think they establish a good enough pattern to be able to do this. Now you can see that this is a consistent system, meaning it has one common solution. When we say that, that means it has a point of intersection. It is not infinite number of possibilities. There's only one exact spot on this graph where it crosses, and in that spot we can count over and label that point. That point is at 6, 4 right there. You'll notice that 6 and 4 add up to 10, and 6 is also 2 more than 4. That's what the first equation said. So when we check these out, they are going to work. When y is 4, then x is 6. That's a true statement. That makes the first equation true. If 6 plus 4 for x and y respectively, that also equals 10. And we can see that that works. So there's only one solution in this case, and that solution is 6, 4. You can check out number 2 in the next video.